Hello everyone, and welcome to yet another lesson in the Introduction to React course. Today we're going to talk about controlled components. Now, the question that we're going to try to answer today is how do we build components that can be composed easily and seamlessly? Now, React makes it very easy to compose components visually. You just put a component as if it were another HTML element, and that's it. We can nest components, put them next to each other without any limitation, and in a very smooth way. Components don't just have a visual aspect. The beating heart of a component is its ability to process data. And in particular, not only data, but also changes to this data. We could see each component as capable of creating an endless stream of states. For example, a checkbox is an endless stream of states: true, false, true, false, true, false. How many? It depends on the business logic of the application. It depends potentially on API calls, which we don't control, and it definitely might depend on user interactions, over which we absolutely have no control. So how many state changes will a component in general do? Well, we have to assume potentially as many as needed. Unbound, it's an unbound number. And, well, every component has this long thread of information changes, a stream of information changes, of state changes. And the trick to building a large application with lots of components is to braid together all these threads so that they become together a single, strong, uniform rope. That's what we have to do. Now, this is all very abstract, so let's actually start with an example. Suppose that we have a Netflix-like movie catalog, and every movie has a movie preview component in the homepage. And if you hover with the mouse over the thumbnail of a movie preview, then the preview should start, and when the mouse leaves the preview, then the preview should stop. But let's say that sometimes the browser fails to trigger the on-mouse leave event. For example, because there is all of a sudden, I don't know, a pop-up somewhere in your taskbar, and then the browser is not anymore the application with focus, so the on-mouse enter you've seen, but the on-mouse leave you haven't. I've actually seen this bug in production many, many years ago. And now what happens is that, well, one movie preview is playing and will actually keep playing, and then as the mouse enters another thumbnail, now you have two movie previews playing. And because every component has its own state, there's no way for a component to say, I'm playing, and the other component should stop playing, because every component has its own state hidden in the depth of its own heart. And absolutely, not only is this a true story, but it was an actual nightmare, because the dev team tried a million hacks and workarounds without success before moving to controlled components like we are going to learn to do today. Also, another note, this technique is very old, so it's a decade old. It has been recommended since the beginning of React in the React documentation, functional/controlled components. And it's kind of funny to note that in the meanwhile, we had Flux as a state management library is dead, because it didn't really deliver on the promise. Redux as a state management library is dead because of the hooks state management library, which seems to be thriving at the moment, but that's only because it's quite fresh. And in the meantime, there's people talking about, oh yeah, but maybe we should use Zustand, etc. Whenever you see lots and lots of different frameworks over time trying to solve a fundamental problem that is deeply tied into the business logic of our application, I think you should always ask the following question. Is this a problem that we can and want to solve with a framework, or is this rather a problem of a fundamental nature that has to be solved with software engineering? Today, we're going to see the software engineering approach. I don't want to show you something that in a couple of years, as the mode of React and JavaScript frameworks comes and goes, and people say, oh, a new framework, let's all move to this, it's going to be awesome. And then you learn something and you build software with it, and after a couple of years, it's all crap that no one maintains anymore. So, yeah. All right. Now, the solution to all of these problems actually lies in this global approach to state management and isolation of components. And the idea is that we will build a controlled, or in functional terms, immutable or stateless or idempotent components that do not save their state internally, but rather they receive their current state and their set state function from the parent component. And of course, the parent component is also controlled when we use this pattern, so it receives the current state and the set state from its own parent and so on, so that we bubble up the set state requests, so that we can also perform validations or any sort of other operations at the level where all the information has been bubbled up together, because in the single movie preview you only have one bit of information, which is which component is playing, which movie preview is playing. And at the parent level you have information about all of them, and so that is where this kind of coordination can happen. But maybe some other coordination happens at even a higher level, and so you have to wait to be able to bubble up your state changes to the appropriate level to perform any operations. There's only one component with state, which is the root component. All others are fully or mostly controlled. You could argue that, for example, having things that only impacted the visuals of an application, like a toggle for opening or closing something, might be state inside the component, but I've also seen situations where a designer rightfully says, well, but when you click on the menu, you want to close, to collapse all of the widgets in the main page, and yeah, you can't do that if those widgets store state in an internal state, internally. So, now, we are actually going to go back to our products now. We had just made products deletable. So let's go to the products widget. Oh, no, in the right place. Yes, the products, the main content. Yes, so we haven't properly added the products rendering yet, even though one might argue that this bit of code should be refactored into the products, but for now we don't care. What we did, which is actually quite ugly, is that the deletion button is outside of the product widget itself. And why is this quite bad? This is quite bad because from a styling perspective, the visual structure will be determined by the product, and the button will be in visual harmony with other elements of this product, card, visualization, whatever. So we really don't want to have the deletion button outside of the product. Also, it really is kind of ugly because, you know, single responsibility principle, so everything that has to do with the product and its state changes should really be part of the product itself, and not the main content state or the products widget, which we don't really have, but we should. Okay, so we go to the product, and this is indeed where we want to have the button. Now, you know, I understand nothing about design, so I'm just going to shamelessly add an unstyled button that an expert would, you know, make proper at a later time. Let's say that this is delete, and then of course we get on click. Don't really care about the argument to on click. What do we do here? Well, what we do is quite simple actually. We're going to make this product properties controlled. So instead of getting the product and nothing else, we also get on delete, which is a function from void to void. I do have fun, yes, very good. Then, in here, in the button, I can simply invoke props.onDelete, and of course I immediately get an error in the main content complaining that the product is missing a non-delete callback. So there's an actual property. Now, no worries. Actually, you know what? I'm going to take this and just paste it. Oh, too many. Yes, sir. Okay, so first of all, let's test this. Now we have the three cars. Let's delete one, and you can see it has been deleted. Let's actually think about what happened for a second. So we are providing onDelete, and well, the product can't really delete itself because it only knows its own data. So this state here, what do? Do we want to set undefined for a product that has been deleted? This would be kind of silly because, yeah, you really want to be able to remove the product. So deletion of a product means removing it from this map here. Well, actually not this one, from the one in the main content state. Yes, so deleting a product requires removing it from this map. Obviously also requires performing an API call to the backend that says actually delete this from the database, etc. But from the React perspective, the product is only deleted when it disappears from this map. So this is the proper removal of the product. And we absolutely don't want to pass to the product state anything more than just the product itself. Because, I mean, come on, like the product shouldn't know anything beyond yeah, its name, description, image, and that's it. So what we get is a sort of, well, okay, we use it as a sort of warp gate to affect the state of the parent, but we can't really affect the state of the parent directly. What we do is we request deletion. So yes, I call it onDelete here, but a proper name would be request deletion, you know? But this would, it does sound kind of cool, but it doesn't really add anything to the application. And here, when the button is clicked, we request a deletion. Now, imagine, for example, that we don't want to end up with an empty set of products. Then we could say, okay, here, we never really want to remove the last product. So, I am going to get the main content state, and I'm actually going to pass the main content state to the underlying updater, but only, so I'm going to say if the main products dot size, if there is one product, then I'm going to skip the whole updater. So I don't want to delete the last product. Let me try. So delete, it works. Delete, it works. Oh, no, this definitely doesn't work. I'm wondering at this point. Okay, it seems happy. 1, 2, 3. Okay, now it worked. And this is an example of, let's say, yeah, I don't want to say global validation, but yeah, a validation that is rightfully only performed by the parent. And in this case, yeah, the product itself. That's why I said a very appropriate name for this property wouldn't be onDelete, but request deletion, because really, you can't control whether or not the product is actually going to be deleted, because there might be some business logic, such as, for example, we never want to have a product catalog that is empty. So, yeah, but I'm going to remove this somewhat ugly business rule, because, yeah, I mean, it would depend on the application. Okay, now the change so far is minimal, and that is actually good because we never really want to have these kind of end-of-the-world refactorings that are very risky. But indeed, well, not only there are some subtle differences, but now the product carries all information about what it's supposed to render, and it is a bit more modular with respect to the state. We are not done. Let's actually move the whole product state to the main content widget. Why? Because now the product actually is stored twice. Once in its own state, but the second time is in the main content state, because we have the products here, because we do need the initial value of the products to pass down, and this is in the and this sticks to the main content state because it's used to initialize the main content state. Here, yes, when we call when we call the initial use state with the default values. But then the single products, they get a copy basically of the product information, which is then adjusted. So let me show you what I mean. I'm going to print the main content state here. So at every re-render, we get to see the main content state. Let me refresh. Okay, now we see that there are 3 products. Okay, and they, you know, have these are maps. So first you see the key, which is 1, the ID, and the name is Fiat Panda, blah blah. Okay, if I delete the Fiat Panda, okay, now the products I get are 2 products. They are stored by ID. Yeah, the storing by ID is not really deterministic, so the map can store them however it wants. But we see there's only 2 cars left. Look what happens now though. I'm going to change the state, but actually the products are not changing in the parent. So yes, of course, this data has been stored in the state of the single product, but now if anywhere else at the level of the main content and the main content state we try to access products, there's a mismatch between the information stored here and the information stored here. So we're going to fix this. How are we going to fix this? Well, we are going to head over to the product and we're going to make the product a controlled component, meaning actually, no, this I'm going to leave. Meaning that I will get from in the product properties, well, the product would be the current state, so we're covered, but we also get the change product, update product, set product. I do like set product, to be honest, which is a function that takes as input, well, an updater over product, and well, doesn't return anything whatsoever. Oh. Let's refactor in such a way that the camera doesn't get in the way. Oh, very good. Okay. Alright, so now the product properties receive the current value of the product, a function to set the product value whenever, or better yet, to request setting or updating the product. And here is the updater that this product would like to apply on the current value of the product, and then we have the onDelete function. Here, in the product itself, now the state and the set state will now come from the properties. So props.product and props.setProduct. And look, the great news is that the component is exactly the same. There is no change required. Everything still just works. But now, whenever we invoke setState, what happens? Well, that we request a change in the state to whatever the parent component set. Now, the product is going to be P. This is definitely still the case. And set product. Actually, you know what? I'm going to delete to change this to delete product to be more in line with the naming of the set product. Here we have the product updater function. I'm going to call it underscore because I don't really care. I don't want to call this product updater or a requested update to product. And well, I do have to set the main content state. I do have to change a product. The product ID, well, is the one coming from the map. The updater to the product would be underscore. And that's kind of it. So probably it does work. Exclamation marks, yes. And now you can see, first of all, there is no copy of the product inside the product widget itself. And second, all information about the products is stored exactly once in the main content state, and you can see the exclamation marks. Now, I will show you another example of let's say silly validation. So we have these products, but what I want to do is I want to avoid our catalog to be too cheap. I do not want 2 cars from I don't know, the Fiat brand, all right? So, let's see. Now, so what I'm going to do, and this is where the updaters actually start coming in handy, is I'm going to, okay, first I'm going to intercept the product updater itself, then I'm going to get the main content state explicitly, then I'm going to get the main content state. I will mark them sequentially. So main content state 0 is the main content state at time 0, so it's the initial one. Then main content state 1 will be created by applying main content state, by applying the actual change to the product. So this is the desired change to the main content state itself, to the current main content state. And now we have two main content states. The first one, the original one, and the one updated. Mind you, we've just created this variable. This hasn't been saved or propagated anyway. So, if, the number of Fiats at time 0, this was main content state 0, dot products, dot count by, no filter, and then we have the product, and the product dot name dot includes Fiat to lowercase. Yes, okay. Dot count. Okay. And then we have the new number of Fiats, which is the very same over main content state 1. You might or might not want to turn this into a utility function. Maybe even in the main content state itself, if this is part of the common business logic, which probably it is. If the number of Fiats 1 is greater than the number of Fiats 0, because if this was the initial content state, we also don't want to screw around with preventing updates. So if this is the state that, if the state came in with 2 Fiats, then we leave it be. But if it's grown and number of Fiats 1 is greater or equal than 2, then I return the main content state 0, so I prevent the update. Otherwise, I return the main content state 1. I don't know if you want to have the else or not. And there we go. Okay, now, is it compiling? Yes, it's compiling. Let's refresh. And let's try to add the T to Fiat, and it's just refusing completely. Like, no, you cannot have the second Fiat. Again, this is quite a silly example, but you can see that we can now perform validations across products. So instead of just being bound to only the information that was available inside the product itself, and that's it, we now have gained the ability to perform validations and synchronizations, you know, this braiding of the different threads of the state changes together, well, not globally, because there might also be other stuff in this application. So for now, the main content state is everything, but yeah, I mean, there's no reason why this should stay. And in that case, we will be able to decide at which level in the state hierarchy we want to perform this kind of coordination. Okay, so indeed, let's extend the state of our application with an orthogonal, an independent addition. Namely, let's add a fake login system. We will allow users to log in without backend and validation for now. And after a user has logged in, we want to store this in a current user state. And as is quite common, we will restrict the ability of users to edit products, and we will only allow logged in users to edit a product. If no user is logged in editing will be disabled. Okay, and this creates an interesting interaction between the state of the login widget and the state of the main content of the application. So, in particular, the state of the login widget needs to be propagated or shared with the single product widget and also the products widget, which once again we don't have, in order to prevent updates depending on information about the user. But the current user state should not be modifiable in any way by those widgets. And we also want to prevent other programmers in the future working on the same code base, namely ourselves in this case, from forgetting that the login information, the state of the current user, should never be changed by any other widget than the appropriate one. So it shouldn't be changed by the product, the products, or the main content widget. Okay, now, we're going to build this. Well, we're going to build this inside the main content. Could be inside, could be next to it, doesn't really matter that much. Well, we are going to store it in the main content state anyway. Okay, so this will be the authentication. Okay, very good. And inside authentication, we're going to create an authentication state. There we go. Okay. Now, we have the authentication state, current user state. It doesn't really matter that much. And well, actually, first we need a user. This should go to a models folder, perhaps, or something related to the API. We could sort this out a little bit better. For now, let's focus on the flow of information across the state. Okay, the authentication state will be either a user and a kind stating that we are logged in, or, well, we need a login form state, because then we're going to show the login form. So login form state, which is going to contain an email and a password. The password we're not going to be carrying around as user information. After you're logged in, we just store the email. But while we're logging in, we need to also store the password. And I'm going to use exactly the same pattern, so the login form state. And this will be logging in. Okay, and for now, that's enough. Shameless plug, if you would like to get a refresher on what this means, remember, there's an Introduction to TypeScript course out there. Okay, now, it is of course a good practice to define initial values for the whole state, and as a matter of organization, because eventually, you know, the user and the login form state, they might be moved to other files, or they might be, you know, there might happen further splitting. So to define the initial state also for these partial states. So the initial user will be, well, actually the initial user, I will make it, well, I will make both of them actually authentication states. And this will contain the email, which of course is empty, and the kind, which has to be logged in. Why is it unhappy? Oh, just a matter of white space, okay. All right. Oh, this is initial user. No, let's organize this better. Come on, we can do better. So const authentication state, and we will export this, and then here we have the object, and then we have the default values, and let's turn this into a sort of repository. The IntelliSense works so much better when you have such objects. Okay, so initial logged in authentication state. I always have these moments of laziness, you know, but then I'm happy I catch myself. Okay, and then we have the initial logging in authentication state, which, why is it unhappy? Oh, yes, the colon. This is terrible, by the way. Why did no one ever think of perhaps uniforming this syntax? Okay, anyway. And this will be logging in, and of course the password is missing, and the password will be an empty string. All right, very good. Okay, now let's define some updaters. So, for example, when we understand that there will be a transition from logging in to logged in when you press the login button. Obviously, there's not an API yet. We'll see that later. This will be from logging in to logged in, and this performs no validation. So it simply picks the email. Let's say if the email is not empty, you know. So this takes as input. Well, this is just an updater actually. So this takes as input the current authentication state, which is an authentication state, and returns an authentication state. Okay, and what does it do? It simply checks whether or not the email dot length is greater or equal than 1. So if it's not empty, then it's okay. Then we return. Let's actually accept the email here, and let's accept the email and the password. Yes, so email and password. Actually, when the name of the key and the variable that we're assigning is the same, then we can just omit the trivial binding. Okay, so when the email has at least one character, then we just accept it. And now I'm going to call authentication state dot default dot. Now we are logging in, and we go to logged in. So I'm going to just pick the email. Otherwise, it's a no operation. So I simply keep the current authentication state. We could also say that we want the kind of the authentication state to be logging in, and also for an email to be present, because it doesn't make a lot of sense to transition from logged in to still logged in. Maybe there will be other states in the future that we don't want to accidentally be used in such a transition. So we just conservatively put all the preconditions here. If the preconditions are not met, well, then we just don't do the transition. We keep the state what it was. Again, validation is very important. I'm going to shamelessly copy all of this, and this will be from logged in to logging in. A bit verbose, but there's nothing wrong with being a bit verbose. And the state has to be logged in. This check makes no sense, because if we're logged in, we can always log out. And then we move to the initial logging in authentication state, which, keeps the same email in case you want to log in with the same user, but obviously has no password, and so starts with a password that is empty. Up to you if you prefer to have this logged in, called logged in and logged out, and in the names, depending on where do you want to put, let's say, the where you want to put, let's say, the accent is really up to you. Okay, now we can use a simple updater over authentication state over literally just one single field, which is the email. Actually also the kind, but we don't want to be able to change the kind on its own, because if you change the kind, obviously you need to change other things as well. But because every state has the email, then, well, it makes sense to simply be able to at least update the email comfortably. The password, on the other hand, password requires us to be in the logging in state. So we get the field updater, which is an updater over authentications, no, over login form state of password, I always refer to the type indirectly for the very simple reason that I like to be safe from changes in this definition. Now, this will probably always be a string, but suppose that at some point, there's a password field with some validation information, etc. If I do it like this, then the definition on line 19 doesn't need to be adjusted. But if I put a string here, then it would. Very often not a problem, but also this is basically a zero effort. And also you get IntelliSense, also if you want to do this at multiple levels. Okay, anyway, so we get the current authentication state. And what do we do? Well, first we check. So we put a guard in order to make sure that we can only change the password when the password is available in a meaningful state. So if we are logging in, then we change the password, otherwise we simply return the current authentication state, turning this into a no operation, a no op. Okay, and otherwise, unfortunately, we have to now go for the verbose syntax. It's live. Current authentication state, where the password becomes field updater over current authentication state dot password. Okay, very good. Cool. So, once again, there will be API calls later. Let's head over to the widget itself. So this will be the authentication.tsx. Out of sheer laziness, I will just copy the import statement from another file. And okay, so we can define the authentication properties. I will leave them here for now. Then usually we like to define them in the state itself, but because they might change quite a bit as we play around with stuff, I'm going to leave them here, and then we move them over to the authentication state itself. Okay. Now, what properties do we want to accept? Well, the current authentication state, which will be an authentication state. And, well, set the current authentication state, which takes as input a function that takes as input an updater that processes an authentication state and returns absolutely nothing. If, by the way, we want the parent state to be able to give us a validation result, then here we could say something like success, or I don't know, kind error, and then kind error, and then the message be, for example, So if we want the parent to actually be able to feed information back, so to have a bit of a two-direction communication stream, instead of just throwing the updater into the callback and then getting nothing in return, well, then you can always just say that this thing returns a value, which is then defined by the parent into which this that calls this widget. Okay. Now, then we can define the authentication widget itself, or we'll take as input properties, authentication props. And once again, really don't be fooled by the desire that a lot of people seem to have to not have to write this trivial code. The battle is not won when you don't write very simple code with good composition properties. The battle is won when we tame the complexity. Okay, so what is the first thing we're going to do? Well, we're going to check the current authentication state, and we're going to check the kind, because depending on the kind, we're going to do something different. Oh, I was expecting more intelligence here. Okay, so if we're logging in, then we need a form. Otherwise, well, we just need some login information and perhaps a logout button. Okay, so for logging in, well, actually I'm going to start with the second because it's a lot easier. Here I'm going to say that we are logged in as, and then current props, current authentication state dot email, and the logout button, when clicked, what is it going to do? Well, it's simply going to change the state. And you might wonder, to what? Well, okay, this callback expects an updater. So let's go get from the updaters in the authentication state. We are logged in, and we want to go back to logging in or logged out. The check has already been done, so current authentication state. Okay, here we have a minor annoyance. Oh. Let's see. So from logged in to logging in. Oh, how truly silly of me. No, that's it. Of course, the function isn't updated already, so it's going to be set current authentication state that takes care of injecting the latest state whenever this is available. Okay, so that was easy. Now, in case we're actually logging in, let's create two input fields. The first one will be of type email, and well, the value, the current value, will come obviously from the current authentication state.email, and on change is going to invoke, well, of course, set current authentication state. This is kind of always the beginning of everything. Then we get the authentication state updaters, and we want to change the email. So we have the email and the password, of course, and here we replace with the new value, which comes from e.currentTarget.value. So we get signaled the new value. Okay. There is a little bit of boilerplate because we call the set current authentication state, and you might imagine that actually, this pattern is so common that maybe there is a design pattern there in the books that allows us to automate this invocation of the set current authentication state, and spoiler alert, there is, but we're going to see it in the advanced React course. So for now, a little bit of trivial repetition that doesn't hurt in any way. Okay, now for the password, well, it's not going to be particularly exciting. There we go. All right. So the widget itself, is easy enough, but I also need to be able to actually log in. So login, and here we call the from logging in to logged in, which will attempt to log in. So there are two levels of validation. One in from logging in to logged in, because we need to have a length of at least 1 in the email field. But some other validation might actually happen in the parent component or in connection with API calls. Okay, now we go to the main content state and we extend it with the authentication state. And this is kind of killing me. This really should be products state, but yeah, okay. There's homework. And here the authentication will be the authentication state. Yes, very good. Of course, in the default value, in the default constructor, if you will, of the main content state, the authentication will be authentication state dot default dot initial logging in with 2 empty strings. There we go. And we're not breaking pattern. All right. Now, let's add a simple updater. I'm going to copy this again shamelessly. Authentication. There we go. Okay. And now in the authentication widget itself, in the main content widget itself, I can just put the authentication widget here on top. Of course, the authentication widget wants a current authentication state, which we will just pass down from the main content state dot authentication. But of course, we also want a set current authentication state. And what will this do? Now, first of all, it will call set main content state. And then we want to get a set state action, which is just either an updater or a new main content state. But in this case, we want to get our updater, and we cannot just call the updater directly because we have to embed it in the authentication field of the main content state. But no worry, our main content state dot updaters dot authentication, which will embed the change represented by underscore, which is the updater of authentication state, into the right place in the main content state. And so we have achieved a very nice separation of concerns, because this authentication widget, mind you, has no clue about the rest of the application. It has no clue about where it's going to be used. So this could be moved from one project to the next. And even if your team builds only one single application, it's not about building multiple projects like you would do in an agency. In an agency, this is very useful. It allows code reuse, great, brilliant, very clear business case. But also, if you're building a single product, then the fact that this thing is neatly separate from the rest of the application means that we can move it around, we can refactor the application, we can change the business logic, and this thing is not too tightly integrated with the rest. Okay, now we also want to be able to inhibit modifying the product. Oh no, first we want to test. Okay, so Giuseppe.ju, and the password will be I am Giuseppe, and let's take a look at the state. Okay, so we see that the state is also containing the authentication. That's very good. So these two things are sort of working in parallel. Like these two threads right now, they're kind of, well, they're not really braided. They're just running parallel to each other. There's no braiding happening. Because, yeah, I just removed the product, and now you can see the products are 2 instead of 3, and the authentication state is completely unchanged. Okay, very good. But now we're going to extend the product properties, and we're going to add the authentication state. Or, well, no, for now I will put the authentication state. There we go. So there is now a dependency between the product and authentication, which might be okay, but we might also want to reduce it. And the authentication will be at the main content state dot authentication state. Let's go back to the product widget, and here, for now the fields, but otherwise we could actually let's do this. Let's do a prettier version. If the properties dot authentication dot kind is logging in, so we're not logged in, or no, better yet, if we're not logged in, let's make this more explicit, because if there are other states, then we want to not allow editing. Then we are going to show the read-only version, and otherwise we allow modification, and we also allow deletion. Now let's refresh. Now you can see I'm not logged in, and the products are not editable. And if I log in, the products all of a sudden are editable. And if I log out, bam, not editable again. Very nice. And also, so effortless. So effortless. Yeah, it's very easy to underestimate how the right pattern takes off a load of takes a load off your mind. What I'm going to do though is that, well, there's no reason to give this much information to the product state. and the product widget, because this might cause some extra re-renders because there is too much data coming in. What I can do though is I can simply pass the kind of the authentication. Now you can see immediately that because this is very well statically typed, that obviously plenty of things complain. The first is this, because we don't need to pass the whole authentication state, but just the kind. Because that's really the only thing the product widget cares about, and now I don't have to do the lookup on the kind. So if less data comes in, we give React a tighter version of the state in a sense, or of the properties to think about, and this might cause some speedups, but this is a bit of an advanced topic. And let's test it, let's make sure everything still works. Oh, by the way, let's try to log in, but well, no login is happening. If there is an email, then yeah, you can see that the behavior is exactly as we wanted it. So we deleted the Fiat Panda, we logged out, and here we go. Here's the new database in in all its glory. I'm going to perform just one tiny little cleanup. I'm going to move the properties. I'm going to move the properties into the authentication state. Okay. Quite impressive. Oh, this definitely didn't work. Okay. Oh, actually it did. Partially. Still quite impressive. All right. And there we go. So I do want to make one last remark about just how effortless this thing is. Like, we managed to adopt this pattern. We made the rendering of the products better because now the delete button is inside the product widget where it belongs instead of the main content widget. We added some relatively exotic validation rules to the product deletion, or even the changes to the product. For example, we don't want more than one fiat unless it was already present in the initial state. We have added authentication, we've added a very thin dependency, very focused dependency from products to validate, from the products to the authentication. And this dependency is actually also pretty well documented. If you look at the product properties now, they tell a very clear story. So if you don't want to have to read every component to know what it accesses and what it changes, with this pattern, you just look at the properties, and the properties, they tell the whole story. There is nothing hidden, because set state inside the component is hidden. And this makes it harder to know what the component actually does. So you can see the product gets a product, which is not read-only because, well, clearly there is a relationship between product and set product. The product can be signaled for deletion, but clearly, well, this doesn't do a lot, or doesn't have a lot more context. So it's also quite clear that it's the parent that's going to do the whole deletion, and then it depends on the kind, so the step of the authentication process. And that's it. So in the next lesson, we are going to start moving into the terrain of asynchronicity in order to simulate the fact that the login widget has to actually make an API call. And we're going to put some validation in the API call and start thinking about mocking a backend. And this is a very good practice because well, we can't really assume that the React application is going to run in isolation. As always, well, first of all, thank you very much for joining me here in this tropical location to learn more about React. Second, I understand the temptation of saying, okay, but isn't there a solution to this problem? Why do I have to write these ugly properties? And they are always the same. Well, first of all, being always the same will be a chance later on. And second, do not underestimate that I do have applications that were built something like 7 or 8 years ago in this pattern, and they still run. You can still update them and upgrade React to now React 18 without any issue. This is a fundamental toolkit as a React developer, and being able to do something that will be reliable for decades, it's good. We're kind of addicted to broken and deprecated things in front-end development, but we don't have to. We don't need to chase every front-end, every framework, every library. If it sticks around for more than 5 or 10 years, Great. Otherwise, let's just copy, our good friends from Java and C# and C and C++, where code from 10 years ago can still run properly. It's refreshing not to have to throw everything away just because, a crappy framework has decided that it's crappy and is being rewritten. So please see this as a way to empower you to be more productive now and in the long-term future. Once again, thank you, and see you next time.